Hey everyone, welcome back to the Info Street channel. Today we are starting a brand new playlist on Gate CSE lectures. And for those who have been following our content on SAP API Management and Integration Suite, don't worry, we have got more videos coming your way. But today we will start with something fundamental, which is the sign magnitude representation. So let's dive right into it. Alright, so what exactly is a sign magnitude representation? In simple terms, it is a method used to represent both positive and negative numbers in a binary form. Let's see how it works. Suppose we have a 4-bit binary number. So here you can see the leftmost bit. The leftmost bit is used to represent the sign, and the remaining bits is used to represent the actual magnitude or the absolute value. Now, in order to determine if the number is positive or negative, we see the sign bit. If the sign bit is 0, it means the number is positive, and if the sign bit is 1, it means the number is negative. Let's take an example. Suppose we have plus 5. Now, in order to represent the plus 5 in the sign magnitude representation, for plus we will write 0 because 0 represents the positive number, and the remaining bit, that is 101, it is the binary equivalent of 5, okay, which is the absolute value. Now let's take another example. Here we want to represent -6 in the sign magnitude representation. So the first bit, that is the leftmost bit, it will be 1 because the number is negative, and the remaining bits is for the binary equivalent of 6, which is 110. Let's see how we can represent -21. We will be writing like this: 1, 2, 4, 8, 16. For 16 we'll have 1, for 8 we'll have 0, for 4 we'll have 1, for 2 we'll have 0, and for 1 will have 1. So the binary equivalent of 21 is 10101. Okay, so the overall sign magnitude representation will be 110101. So this is how you can represent any given number in a sign magnitude representation. So now let's discuss the range of sign magnitude. So the range is from -2 to the power n minus 1 to positive 2 to the power n minus 1. Suppose n is equal to 4. For this we need to calculate the range. So it will be -2 to the power 4 minus 1 to 2 to the power 4 minus 1, then minus 1. It will become -8 minus 1 to positive 8 minus 1, which will be -7 to +7. So if the value of n is equal to 4, you cannot represent -8 because minus sign will take 1 bit, and the remaining the value of 8 in the binary representation, it requires 4 bits. So the total bits required to represent -8 will be 5, and that cannot be represented by the 4-bit number. Now let's talk about the drawback of the sign magnitude representation. You see, for -0 and +0, we have two representations. We have 1000 for -0 and 0000 for +0. And because of this, there is a loss of one presentation, and it leads to confusion. Okay, now let's talk about the number extension. So in computer, the size of a location is fixed, and it is often required to write a smaller number into a larger number space. So this can be done by a number extension. Suppose we have a given number as 0110, and we need to represent in a 8-bit format. For this, the sign will be written in the leftmost side, and the remaining magnitude bits will be written on the right hand side. And we will pad the remaining empty cells with the 0 if the number is positive. Okay, one thing I like to mention it here, that although sign magnitude is in the standard for modern arithmetic, it is still used in certain applications, especially where exact precision of the sign bit is needed. One notable example is floating point representation, where sign magnitude is used to indicate whether the number is positive or negative. And that's it for today's video on sign magnitude representation. I hope this cleared up the basics for you. This video is a part of GATE CSE playlist. So if you are preparing for GATE or looking to brush up on your computer science concepts, don't forget to subscribe and turn on notifications. And for all of you who are here for the SAP API Management and Integration Suite content, rest assured we have more of those videos coming up very soon. Thanks for watching, and I'll see you in the next one. Bye bye.